exponentials. Today, we're going to be discussing on how to graph exponential functions. Recall, an exponential function is a function that is some number raised to some power. So our x's, or our variables, are in the exponents now. They're not downstairs as coefficients in front, but they're actually in the exponent. Why is this interesting? Well, now changes occur as powers instead of multiplication. Now there is one restriction, that we don't want our constant here to be 0, because then it's trivial. Nor do we want this constant to be negative, because then when I have an even power, it'll be a positive value, and if I have an odd power, I'm going to have a negative value. We don't want that changing, because then our graph will look very weird and it just won't be very continuous. So we want something smooth. So here I have my xy coordinate, and I'm going to plug in some values, maybe a -2, -1, +1, +2. Why am I putting these? Because in order to graph, we want to create an f of x table. -2, -1, 0, 1, 2. Let's create some lines here, because now we're going to be tabulating the results. If our f of x is, let's say, 1/3 raised to the x power, f of -2 is when I just replace x with a -2. Recall, when something is raised to the negative power, that implies that we have to take whatever's here and put it in the denominator raised to that positive power. So it's going to be 1 over 1/3 raised to the +2, not -2. The cost of having that negative go away is to put it in the denominator and put a 1 on top. Okay? So once we square 1/3 in the denominator, I get this is equal to 1 over 9. Because 1/3 times 1/3 is 1/9. Then when I multiply by reciprocals, I get that this is equal to 9. So right here, we want to have 9. Alright? We're going to close off our calculation and only have the final numerical results there. Let's see what f of -1 is. Well, f of -1 is 1/3 raised to the -1 power. Now, that means I got to put it 1 over 1/3 raised to the +1 power. But that's merely just 1/3. And then when I flip by reciprocals, I get this is numerically equal to 3. Now let's do f of 0. f of 0 is 1/3 raised to the 0th power. Anything raised to the 0th power is equal to 1. And I will actually create a video about that today, proving why that's true. Most of your teachers don't prove that it's true. They just tell you anything to the 0 power is 1, but not with me. I want to show you the reasons and the explanations that are omitted by most of your educators. I don't know why they omit it, because it's very interesting when they tell you the reasons behind why they're telling you what they're telling you. When I was a student, I didn't like it when teachers did that. I thought they were lying to me. I didn't believe them. And so, without justification, I just kind of mentally checked out and didn't want to listen to the teacher anymore. But I will prove in another video why anything raised to the 0th power is 1. But right now in this video, let's just treat this as a fact and take it. I'm going to show you in this next video why that is true. f of 1 now is 1/3 raised to the 1 power, which is just itself again. So here we get a third. Here, f of 2 is 1/3 with x replaced with a 2. Well, that's just 1/3 squared. That's 1/3 times 1/3. That's 1/9. So over here I get 1/9. Now I come here on my plot. I figure out where are we at -2. At -2 I'm at +9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I go here, I put a dot. This is at 9. I go to -1. Where am I at -1? I'm at 3. 1, 2, 3, -1, 3. I put a dot. Where am I at 0? At 0 I'm at 1. 0, 1. I put a dot. At 1, where am I? I am at 1/3, so I'm probably down here. I put a dot. Where am I at 2? I'm at 1/9. I'm right here, I put a dot. Once I'm done putting the dots, now it's time to connect the dots, okay? So we put a line that goes through each of these dots, and that is basically what our graph will look like. As we can see, the graph is dying as we choose larger and larger numbers. Why is that? Well, the larger and larger number we pick, the power gets larger. But wouldn't that make it get bigger? Not necessarily, because notice we have a fraction here. 0 to any power is 0, 1 to any power is 0. So let's say I have f of 100. So then I have 1/3 raised to the 100 power. But then this distributes to the numerator and the denominator. 1 to the 100 power is still 1. But 3 to the 100 power is not. It's a very large number. But when we get 1 divided by a very large number, their ratio gets very, very small. It gets very, very small. And so, as you can see from the graph, the limit as x approaches infinity, as we pick larger and larger numbers, this value will approach 0. Okay? So, that's one way to graph an exponential function, is with an f of x table. Next, on the next video, on top of describing what dividing by, or raising something to the 0th power, we're going to discuss why that leads to the number 1.